Okay folks, what I have here is yet another wonderful BK1479B 30 megahertz scope. This particular scope is in excellent condition both physically and functionally. As you can see, there are no surface scratches on the front panel, nothing objectionable about it at all. Has a nice bright sharp trace, nicely adjustable, plenty of reserve. All of the switches are functioning smoothly with no erratic jumpiness or anything. All the switches are functioning properly, as I'm saying here. There's channel B, channel A, both channels, additive. Let's put the signal back on it. We have the sync adjustment. We are in auto right now. Here's normal, no sync, adjusted sync, no sync. Back to auto. That's normal. We have a ×5 magnification for horizontal. Working well. The focus, very sharp. Slope adjustment. Coupling from DC, high frequency rejection, low frequency rejection, or AC. Source of the trigger, channel A, channel B, external or AM detector. We are in normal mode right now. There's a video mode, and then there's a fixed mode. Something you'll have to read about to understand. Polarity of channel B can be inverted. And pretty much that's it. The case on this thing is in good shape. There are a couple little surface rubs. There's a crack in the plastic of the corner back here, as you can see, but outside of that, looks remarkably well. Access ports from the side. Both sides for channels 1 and 2. So we're going to be taking this thing through its steps, testing it out, and just sort of proving to you that that the condition it's in is an excellent condition. Bear with me. Okay, at this point, what I've done, I have the scope. Right now, the input is grounded, and I am adjusted so that I have 5 vertical divisions above the ground line. I'm on the 0.1 volt per division setting, range setting, and what I want to do is to measure a 0.5 volt signal coming from this power supply. Right now I'm reading 0.497, so 0.5 volt, and I want to see that I'm going to be able to rise 5 divisions on this screen. Once I've proven that at 0.1 volts per division I rise my 5 divisions, I'm going to check my calibration output and see that it has 0.5 volts output as well, and then we're going to use that calibration point to check a number of scales. So once again, let's just make sure we zero ourselves. Alright, and then we're going to hit the DC, and we see that we instantly rise 5 divisions. Ground, 5 divisions. Alright, so now that I know that 5 divisions represents a half a volt, give or take a couple of hundredths, I'm going to now connect up my scope probe, the calibration point, and we're going to take a look at how many divisions we have. Okay, so what I see is 1, 2, 3, 4, 5 divisions. So I am getting a half a volt out of my calibration point. It's a good thing to know. We're going to use that fact here in a moment to check some of the scales. Alright, so now we have ourselves adjusted to the 1 volt per division setting. We are achieving a half of a division, so we have 0.5 volts. If I go to the 0.5 volt per division, I see that I am now 1 full division. If I go to the 0.2 volts per division, then I see that I am rising 2 1/2 divisions to 0.5 volts. 0.1 volt per division, and I go up a full 5 divisions. So there's 4 of our scales right there that we've tested, and we achieved the appropriate response. Now at this point, if I change my probe from a ×1 probe to a ×10 and implement the built-in voltage divider, I am now dividing all of my inputs by 10. So I am at 0.1 volts per division divided by 10. I'm coming up a half a division, so that would be 0.05 times 10 would be 0.5. If I go to 50 millivolts per division, times 10 would be 500 millivolts, and that would be 0.5. If I go to 20 millivolts per division, I'm rising 2 1/2 divisions to 0.5. 10 millivolts per division, a slight shift. Okay, there's our 0 again. And we are rising exactly 5 divisions, and we have 0.5. So we have gone from 1 volt per division through 1, 2, 3, 4, 5, 6, 7 scales out of 10. So 7 out of our 10 we have measured and got exactly the proper response. Alright, we now have channel B connected to the same calibration point, and we are looking at channel B on the screen, and we're going to go through the same steps. We are currently set at 1 volt per division, and we see that we are up a half a division. If I go to a half volt per division and adjust for my 0, I'm coming up 1 full division. 0.2 volts per division, and I rise 2 1/2 divisions. 0.1 volt per division, and I go 5 divisions. Alright, so now I go to the ×10 setting on the probe, and I see that I am at a half a division, which would be 0.05 volts times 10 would be 0.5. 50 millivolts per division, coming up 1 full division, so 50 millivolts times 5 is 0.5. 20 millivolts per division, and we have 2 1/2 divisions, so 0.5. And 10 millivolts per division, we rise 5 divisions. So once again, channel B mimics channel A, and the inputs are all measuring properly vertically.